Hello, I am Mr. Warehall, and we're going to have a crash course on linear functions. First, let's see if you can identify between these two tables which one would represent a linear function. Now, if we look at the number pattern between the x and the y for the first one, we'll notice that to get from 3 to 6 to 12 to 24, we are multiplying by 2 every single time. This is not a linear relationship. This is called an exponential relationship. Now the second table, if you'll take a look here, we go from 3 to 5 to 7 to 9, we are increasing by 2. We're adding 2 to the y every single time x is increasing by 1. This is a linear function. Oops. When variables change at a constant rate, the relationship is a linear function. When I say constant rate, I'm talking about adding a number every time, the same number every time. So this one, not linear. The second one is linear. And again, because the x and y are changing at a constant rate. Every time x is going up 1, y is going up 2. Now the second thing that's really important is that ordered pair right there. When x is 0, y is 3. This is our y-intercept. Now going back to this constant rate of 2, do you remember what we call this in math class? This is called the slope. And in this particular example, it's 2. Slope can be defined as the change of y divided by the change of x. And if we notice, x is increasing by 1, so that would be the change of x, and we put that on the bottom. The y is changing by 2, so that'd be in the numerator. And 2 divided by 1, you see, is our change of, the constant rate of change, or slope. Now, this table is a bunch of ordered pairs that we can graph. So let's graph them right now. The first one, 0, 3. Got this fancy-dancy grid here. So we have 0, 3. And I put a dot right there. Again, how did I get that dot? The coordinates 0, 3 in the table are indicating that's where we put our point. Let's go on to the second point. 1, 5. Where should we put that one? Well, we always start at the origin. The x is 1, so we go to the right 1. And the y is 5, so we go up 1, 2, 3, 4, 5. And we could do the same for the 2 and 7, 3 and 9. So we have 2, 7. Whoops. We go 2, 7. There we go. Now it's in the right spot. And then 3, 9. Now if we connect all those dots, look what we have. We have a straight line. And that's why we call this a linear function or relationship. So this line is a visual representation of that table right there. Now, we can also express it in an equation. And the only two things you need to know for an equation is the y-intercept, which is our starting point, 0, 3. It's right there. And the second would be the slope, which is 2, because it's going up at a constant rate of 2. When we write our equations, I don't know, we probably, you know what, we're going to put that calendar. Okay, y equals mx plus b is slope-intercept form. And it's a way to write an equation. Now, m stands or represents the slope. And the slope in this case was 2. So I simply make the coefficient of x 2. There it is. You see the 2 in the table. You also can see the 2 in the slope. Look, I'm going up 1, 2 every time I go over 1x. Up 2 over 1, up 2 over 1. They're like steps. Now the other point, the B, this is our beginning point, is our y-intercept. So that was 3. And now we've represented this linear function as an equation. So we have the table, the graph, and the equation. They're all linked. Same information, just a different way of representing it. Now what I would like you to do, here's a table I put together as well. I would like you to write this down, graph it, and then come up with the equation. Hit the pause, and I'll get back to you in a second. Let's see how you did. Did you notice that we're going up at a constant rate of 3? Y is going up 3 every time x goes up 1. This is a linear function, or a linear relationship. Also, did you notice that our y-intercept is -4? That's the y value when x is 0. That's going to be our y-intercept. Now, if you look over here, we've graphed those ordered pairs. I first graphed my y-intercept, 0, -4. And then I graphed the other 3 coordinates, 1, -1, 2, 2, and 3, 5. I connected them, and look, we have a straight line. It's a linear relationship. Now, the last thing we need to do is write an equation. Now, back to this. Y equals mx plus b. M is the slope, b is the y-intercept. So what do we put in for m? That's right, we put in 3. And the y-intercept, what's that? -4. So all I need is that y equals and that x, which won't change. And voila! Bam! We have our equation. Y equals 3x minus 4. One more. Let's say I start off with the equation, and you have to give me a table and a graph. Could you do that? Let's say we did this. Let's say I gave you y equals -2x plus 1. I would like you to make a table and then graph it and see how you do. All right. The first thing that I noticed was the y-intercept is 1. So in my table, 1 is next to 0 when it's x. Even if I take out the x and put 0 there, I simplify my right expression. -2 times 0 is 0. 0 plus 1 is 1. So when x is 0, y is 1. Now the next thing I identified, is the slope. That is our constant rate of change. So when I went up 1 for x, I'm going down 2 for y. Now I have my ordered pairs. And I've graphed them. 1 is my y-intercept. My slope is -2, so I go down 2, down 1, down 2 over 1, down 2 over 1, down 2 over 1, just like steps. And that is a crash course of linear relationships. Thanks for watching.